Hello friends, welcome back. In previous tutorials we studied about the protocols which can be used for noiseless channel. In this tutorial we are going to study stop and wait automatic repeat request protocol. Right? This protocol is used for noisy channels. Right? So what happens? This protocol adds a simple error control mechanism to the stop and wait protocol. Right? What is the stop and wait protocol? That we have already studied. Right? In this protocol, what happens? The frames are numbered. In this protocol, a field is added to the data frame to hold the sequence number of that frame. Right? And what happens? In this protocol, redundancy bits are added to data frames to detect and correct corrupted frames. Right? So what happens when the frames arrives at the receiver? It is checked. If it is found corrupted, then it is silently discarded. Right? So what happens? In this protocol, the corrupted and lost frames need to be resent. Right? So what happens in this protocol? In this protocol, when sender sends a frame, it keeps a copy of the sent frame. Right? So what happens in this case? In this case, the sender keeps the copy of last frame transmitted until it receives an acknowledgement for that frame. Right? And at the same time, the sender starts a timer. If the timer expires and there is no acknowledgement of the sent frame, then the frame is resent and its copy is held and the timer is restarted. Right? So what happens in this protocol? In this protocol, the corrupted and lost frames need to be resent. So for that, what happens in this protocol? In this protocol, when sender sends a frame, it keeps a copy of the sent frame. Right? And it keeps the copy of last transmitted frame until it receives an acknowledgement for that frame. And at the same time, the sender starts a timer. If the timer expires and there is no acknowledgement for the sent frame, then frame is resent. Right? And its copy is held and the timer is restarted. Right? So what happens? The acknowledgement frames, they can also be corrupted and lost. So what happens? The acknowledgement frame also need redundancy bits and sequence number. Right? So acknowledgement frame also needs redundancy bits and sequence number. So what happened in this protocol? In this protocol, acknowledgement frame has a sequence number field. Right? So in this protocol, the sender simply discards a corrupted acknowledgement frame or ignores an out of order one. Right? So what happens? The data frame uses a sequence number and an acknowledgement frame uses an acknowledgement number. So in this protocol, what happens? The data frame uses a sequence number and an acknowledgement frame uses an acknowledgement number. Right? Now what is this acknowledgement number? Now what is this acknowledgement number? The acknowledgement numbers always announce the sequence number of the next frame expected by the receiver. For example, if frame with sequence number 0 has arrived safe and sound at receiver, then the receiver will send an acknowledgement frame with acknowledgement number 1, which means that frame with sequence number 1 is expected next. Right? So in this protocol, what happens? When a sender sends a frame, three things can happen. One thing that can happen is that the frame arrives safe and sound at the receiver, and then receiver sends an acknowledgement and the acknowledgement arrives at the sender, and then sender sends the next frame. Right? Now the another thing which can happen is that the frame which is sent by the sender, that frame arrives safe and sound at the receiver. Right? And receiver sends an acknowledgement, but this acknowledgement is corrupted or lost. So what happens after the timeout? The sender will resend the frame, and when this data frame arrives at the receiver, its sequence number does not match the next frame expected by the receiver. So receiver sends an acknowledgement to the sender, and this acknowledgement, however, reconfirms the previous acknowledgement instead of confirming the frame received, right? Now the third thing which can happen is that the frame is corrupted or never arrives at the receiver side, right? The third thing which can happen is that the frame which is sent by the sender, that frame is corrupted or never arrives at the receiver side. So in this case, what will happen? In this case, after that timeout, the sender resends the frame, right?